I'm Michael Manansala. I'm from Zollner, and my colleague Christian Tremel is based in the Europe, our Germany headquarters. I'm in the Bay Area. Why we are here today? We just joined OCP in the power rack track engineering module. So our aim is to understand and be part of the conglomerate in standardization. Okay, so I'm going to talk about the unified network fabric, because we've been doing this ever since. It's one of the base core of the business of Zollner. We are a non-IP. We can call /ODM. We design, but we basically don't own the design. It's all the customers or the final OEM basically owns everything. But we service the industry on many ways. Okay, this is our plant in Hungary, one of the largest footprint of the Zollner, the largest in terms of manufacturing, from sheet metal, ground zero sheet metal, all the way up to the rack, and level 10. Basically, we integrate up to level 10. So before we ship and deploy it to the floor. I'm talking about the data center and also the telco. Okay, it's founded in 53 years ago. The base is in near Munich. But it's been part of the Bavarian, I would say, renaissance. So our founder, starting from Mr. Zollner Sr., winding the coil, and then ending up doing sheet metals all the way up to the automotive. And then in the 80s, IBM basically set foot in the European continent, and Zollner became more, I would say, adept to the data and office technology. So this is where our footprint started. Okay? And we still are a private entity. It's still family board run, but we have 18 locations worldwide. Okay. Some of the customers basically that we serve is our system integrated, not only cabinet, racks, and modules, and portion of the selected picture here we just saw earlier, the Schneider Liang part of them. We do service as one part of our customer base, and a couple of mainstay member or OCP, say mainstay partners. Okay, but I'm here today to talk about the value proposition of what Zollner believe can contribute to the community. Okay. So I mentioned here we do sheet metal from the phase 1 of the rack, say process step progress manufacturing, up to basically level 10. But doing so, we were requested 3 years ago when we enter more deeply in the Silicon Valley. We set up our plant. It's a test prototype and slash I've seen the Soins test, the EMI, things like pre-compliance. It was requested by our customer that we have that kind of facility. So please feel free to be invited, come to us in the US when you need some pre-compliance assistance or I would say support. And in Europe, our headquarters is supported by Christian. Okay, so we can be a extension of your laboratory, so to say. Okay, but here for Zollner's topic, we deliver. We basically as a company supplied the design ODM, and then build it, white label it, basically, and ship it. But on the end customer side, where the node are basically terminated, there are some legacy still data centers that own and runs the, I would say legacy, not legacy, but the lower echelon data speed channels on the 10G up to 40G. So here I'm talking about not the futuristic or the mainstream technology that we see downstairs. I'm here to basically imply how we can support the existing data infrastructure, okay, in terms of upgrading them to I would say higher bandwidth accommodation, okay. So for level 11, what Zollner can do basically is here. So we can support existing fabric, but with minimal additions of the network fabric that has some elements of hardware available on the what we call the switch level and the LFE, and also the access to the storage area network, basically where the SAN cabinet is. Okay, and basically the goal here is to have a minimized cabling infrastructure of removing or changing the entire, I would say, rack lane or rack row. So Solner basically is more on the top of the rack. We supply mostly the system integrated cabinets on the TOR configurations. Okay, and I'm just basically showing a summation of how not big but how relevant is the legacy data center on the floor today is, and then moving forward to the OCP direction. Okay, so this is one of the installations that we've been doing in Hungary, basically. So we do the cabinet node termination, and you can see here there are very minimal cabling. Now we are integrating this fabric. It's a multimode fiber with the combination of hybrid steel copper termination. Okay, so we use Solner basically develop, and what we can contribute later on. There is a deeper slides that addresses the termination points using the multimode fiber. How do we integrate that and be able to still accommodate the legacy racks? Okay, so we can still service the existing 10G, all the infrastructure or the fabric line, to integrate and migrate it to 40G. Okay, and even basically there are works now that we are working together with one of the cable termination guys, Samtech. So we wanted to be on the higher echelon, the 100G to 200, if it's possible or available now. Okay, so we don't basically dwell much on the virtual machine control system. We don't write it, but we have a partner basically that assisted us. Okay, so to analyze and where the value of Solner is in the floor, basically this is where we are. So we don't right now physically interact or support the other component in the DC floor, but we do have the rack level termination. So in this order, I will just basically kind of map out the hierarchy. The existing 10G switch could be added with a spline of 40 GB. And then this is what the Solner contribution is, the Uplink converter. So we built and basically but through the OEM partner, created the PCE Gen 4 interface. And then from the 40 GB optical switch line, basically we now be able to access and connect, to the motherboard, the CPU, and also the storage area network cabinet. Okay, so how does it go on the map out? Basically, what Solner did contribute here is to create this two uplink converter. So the PCIe Gen 4 uplink will be able to allow to talk through the standard switch, like available OCP approved or verified switch for the 40G and higher. And then basically we can now pump in all the optical lines down here with the ASIC chip. So Solner basically work with the embedded. There are 8 basically streams of 4 right here of UPSF, but it can handle independently 80 gigabits per second of bandwidth. So with this configuration, we will be able to combine the existing legacy copper lines with 10G and lower to 1G up to 40G, basically. Oops, sorry. So just pardon me, I can basically show some partial images, but when we work with the community of the team from Steve, we will be able to share the standards or the white paper over here. So it is just the kind of introduction for us. So this is the Gen 4 PCIe ASIC board driven that basically allows us to uplink the lower bandwidth to the 40G line. And then the termination on the optical side, basically, this is where Zollner did the iterations of the upstream fabric extender. So it's now not proprietary, but it's been used by one of the major DC or data center operations. But in the course of time, we will be able to share this to the community. Okay, so the value basically is, instead of using an aggregator in one cabinet, you can harmonize basically and decentralize the optical termination front end from the telco and mix it up on the existing cabinet. So with these two components, now the legacy rack can be upgraded. Okay. So, but however, this is very important. We have to use a multimode fiber because it has to be bidirectional. Okay. So as a guidelines, we still follow up to the TIA cabinet for cabling specification, the 942. And basically, these are some of the considerations. Reliability, of course, and interoperability. We are trying to understand that more and more as we work with the community or the OCP rack community. And high capacity density, we are here basically on the, phase of integration to a wider rows of cabinets. Okay? And basically our aim, right now we have been upgrading some of the TOR lines on the 40G, but we are looking forward to accomplish and be able to reach this point and be able to be service, or to be able to serve a wider community members. Okay, in the end, the value of the network fabric, universal network fabric, is still on the TOR architecture. So we would like to delve more and understand the other players or other infrastructure so that we can be more flexible. Okay, in the end, so all cabling basically has this kind of distribution limit, but we are up here, so we are not in this mode, just to be very, upfront. And yeah, we want to share that this universal network fabric basically could contribute to a modularity or standardization, as we say so. And then as for now, there are configurations that we were able to wire in the container of like 90 server rack in a row. So that's the kind of the breadth of what we can handle. But otherwise, we will be looking forward to other configuration as well. Okay, and then I/O. The more and more we learn, yeah, we need to understand this portion, the I/O connectivity, as more of the termination points like the QPSF sockets are evolving very rapidly. So we thought like 8 months ago, or 18 months ago, moving 10G to 40G on the live floor is going to be the mainstream for us. But we now see it as we are on the back end, so we have to catch up. So we have to learn and basically understood how we can be a contributor on this area. Okay. So key takeaways from here. The network fabric can be used and be available now, but Zollner basically is a new kid on the block. We wanted to kind of connect with the players right here or the community members. And then our transition experience from 10G to 4G using the FCOE is very well, I would say, stable. Okay, and advantage is the cost and also the time to deploy. Oops, sorry. And yeah, for now, that is the kind of, not value, but introduction that we can make. And we are here to listen and basically take your advice or questions to work further. Thank you very much if you have questions.